I just bought an iPhone 13 Pro, but there's a catch. The person I bought it from thinks it's been run over, and judging by the state of it, maybe more than once. It was sold as not working, and the seller made it clear it might not even be repairable. Chances are, this one's going to need some pretty advanced repair techniques, the kind you've probably not seen in most repair videos. But sometimes taking a risk on something as badly damaged as this can really pay off. So let's see if it's worth it. As always, we start to remove the two pencil lobe screws from the bottom of the phone. And then we turn our heat pad on to about 80 degrees Celsius. Once the phone is nice and hot, we can start to remove the screen by using this razor blade and isopropanol alcohol. You want to rock the razor blade back and forth, applying even but quite light pressure until a small opening appears. Using lots of alcohol won't actually damage your screen if you're using 99.9% isopropanol. Unless the screen has an LCD, then you might damage the backlight. I'm pretty sure this screen is completely dead as it wouldn't turn on, so we don't really need to worry about damaging it at this stage. Next, remove the protective shield covering the proximity flex, and then the shield covering the battery and the display connector. Once the connectors have been removed, we can lift the display. If we head over to the Apple self-service store, we can see that the display for this iPhone 13 is £289, which is almost as much as this phone's worth. Luckily though, my good friend John at the Gadget Geeks on the Isle of Man sent me this cracked display for only £20. He says it works, so fingers crossed the phone turns on. Otherwise, we're going to have to do some more troubleshooting. The phone didn't turn on by pressing the power buttons. Perhaps the battery's dead? The phone appears to be charging correctly. We have the battery icon. And yes, the phone turned on. That's great news. Now that it's on, let's set it up so we can make sure that everything works like it should. Instantly we get a camera not recognized message. This can be due to a number of things. We should be able to repair it. I just hope it's not logic board related. The battery's still at quite a good health. Apple advises we change the battery at 80%, so we still have quite a bit of life left on this device. Now I'm removing the shield holding the proximity sensor in place. Using more alcohol allows me to remove the proximity flex that's stuck down to the back of the screen. Then I use a spudger to gently remove it. Ideally, it's better to get under this glue layer, unlike I've done here. This makes it easier to stick down to the new display. If you're struggling to remove the proximity flex, just add more ISO and heat. It will come off, just be patient. Before I do any other repairs, I want to check that the Face ID is working. Because the display was so damaged, there's a high chance that Face ID will be broken and repairing it is quite difficult. In order to test this, we need to transfer the proximity flex to the new cracked display. I want to take the time to say a massive thank you to everybody that commented and subscribed to my last video. It got over 200 comments and more than 1,200 subscribers, which still blows my mind. We can set up Face ID by moving the screen gently to the right. This removes the need to fully seat the display back into the housing. Luckily for me, the Face ID module is working. I wasn't expecting this given all of the damage to the rest of the phone, but I'll take it. Face ID is set up, so let's check to see if it can unlock the phone too. As expected, it works great. You can see in parts and history that this phone is showing that it's had a new display that needs to be calibrated. We will calibrate the display soon, But first, let's start by seeing if we can do something about this cracked glass. I've turned this heat plate to 110 degrees Celsius. This will be used when removing the cracked glass. But first, we have to remove this proximity flex again. While the heat pad is warming up, we can add some tape to the front of the broken display. This will make the glass come off in one piece when we remove it from the OLED. Now that the heat plate has reached the optimum temperature of 110 degrees, we can flip the screen over and start by inserting a thin bit of cutting wire to the bottom right corner. For the best result, I advise pulling from only one side of the wire. This uses more wire overall, but means there's less chance of a loose shard of glass scratching the polarizer layer. If you're enjoying this video or learning something new, please press the like button and consider subscribing. It really helps the channel grow. My goal is to reach 10,000 subscribers. Currently we're at 6,500, but with your support we can make it to 10 in the next year. The wire kept snapping here, so I decided to lift the frame a little using ISO and this little piece of metal. This allowed me to cut at a slightly different angle and remove the glass from the OLED successfully. The glass and OLED have been separated, so next we can start to remove the frame. I want to keep this frame in one piece instead of cutting it like you might have seen before. This way we can keep it from ending up in the landfill, but also original frames are ever so slightly better quality than the aftermarket ones. The piece of metal and the 99.9% ISO are used to help remove the frame here. This is because although the main part of the frame is glued on, this part is only attached with double-sided tape at this point. I have to make sure I'm really careful at the bottom of the display. Touching this part with any pressure can result in lines on the display, and I don't currently have any specialized laser to fix this. Perhaps I will in the future. Now that the glass and the frame have been removed, it's time to remove the glue that's been left behind. To do this, I'm using delaminating. This softens the glue and allows us to remove it by peeling or rubbing it off. You might have seen in my other videos that I use a spinning tool. The spinning tool is faster, but this gives a better, slightly overall result, as the spinning rod can make small marks on the polarizer layer. I often challenge myself to see if I can pull all of the glue off in one perfect sheet. I once got 90% of the way, but it snapped right at the end. Maybe one day I will achieve the perfect pull. They say a man has to have dreams and goals after all. Maybe this can be mine. Now I'm back with the alcohol, and this time I've got a soft cleaning cloth to remove the small crumbs of glue that have been left behind from the previous glue removal. This process can take quite a bit of time, but the better job I do here, the less cleaning I have to do in the clean room later on. Now that the screen is clean, and before we apply the new glass, I first need to test the display to make sure we did not damage it during the refurbishing process. The touch is working as it should, so now we can move on to the next exciting stage of applying the new glass. I'm aligning the OLED to this mould so that when I apply the glass, it's perfectly in the correct place. The green lamp allows me to see all of the dust and the leftover glue that we did not clean off previously. Even the smallest speck of dust or glue will be visible once I apply the glass, and then we'll have to do this entire process of cutting off the glass again. The OLED is now being completely cleaned with alcohol, so now we can apply the glass. I'm using G-Ochre Pro. I'm not sponsored by them, but I personally believe this to be the best. This glass comes with the glue pre-applied. Once you remove the plastic film, you want to try and align the glass to the OLED quickly. This is to try and limit any dust in the air from sticking to the glass and ruining our hard work. You can see here that I'm using my fingers to pinch the glass to the display. You want to touch the glass as little as possible to the OLED. One small touch should be enough. Any more and you tend to get stubborn bubbles during lamination. This is my YMJ 12.9 laminating machine. It essentially heats up and applies pressure to the OLED and glass in a vacuum, thereby creating a new display. After the machine has finished doing its thing, we can remove the new refurbished display. At this point, it's almost ready to fit onto the phone, however there's still a couple of small bubbles left, and so it needs to go into the bubble remover. This is the M-Triangle M1 Pro Max 14-inch autoclave. This removes bubbles by using high pressure to force the bubbles out. Just make sure you pay close attention to the safety precautions. In this case, equipment start and work, please be sure to close the chamber door. I think what they're trying to say is if you don't close the door properly, things can explode. So we've got to be careful. After 3 minutes have passed, I checked the screen and all of the bubbles seem to have been removed. The last part to do is to reapply the frame. To do this, I have another machine. This is the Nasan automatic glue dispenser. We need to make sure that first the machine is calibrated by aligning this needle to the mould, and then we need to make sure that the glue comes out nice and smooth. Once we know the glue is running like it should, we can align the original frame to the mould and screw it in place so it doesn't move around. One last check to make sure the machine is still calibrated, and then we can start the gluing process. Applying the glue to the frame by hand is very difficult and almost impossible to get an OEM finish. I always try my best to get as close as possible to the original. This is why I've invested heavily on these machines, even though it's still only my second part-time job. At this point, a new ear mesh is placed onto the glass. It sits between the glass and the frame, and it's important to make sure that you have this the right way around, otherwise it's going to be a headache later down the line. I find it easier to remove the frame from the mould before attaching it to the new display. This makes alignment a little less troublesome. Almost at the last step now. Once the frame and the display are aligned correctly, I can place it back into the mould ready for pressing. Before I had this machine, I used to use black cold press glue. I would apply, clamp, and let it dry overnight, and even then it wasn't a super strong bond. Now it only takes 5 minutes to set, and it's very similar to the Apple factory. And that's it. The old cracked screen has been brought back to life. The last thing we need to do is to test that it all works. The colours look fantastic. The touch works like new, and there's no scratches or marks. This screen is so much better than any aftermarket display, especially a cheap LCD. Now we've fixed the screen so it looks and functions like new, we can start to repair the rest of the phone. The frame of the housing's cracked just here, and therefore it's not really repairable. Luckily for me, I have this housing in my workshop. It's in overall good condition, but the rear glass is broken. Let's try fix that. This is the M-Triangle 1S laser machine. It has a 20-watt laser that burns the glue on the back of the glass. This makes the removal of the rear glass slightly easier, but it's still quite difficult. Using these plastic clamps, I'm attaching this housing to the heat plate which I'm using for a bench. Because the glue is so strong even after the laser, I'm using this hot air station set to 360 degrees Celsius to help soften the adhesive. Here I'm using a glass breaker to make it easy to remove the glass. It's much easier to remove it in small parts rather than one big sheet. The last hole I punched in the glass went a bit further than I wanted. Luckily, this housing does not have the logic board inside. You should always remove the logic board and the camera when doing this type of repair. Otherwise, you risk damaging expensive components, and this is never good, especially if it's a customer's phone. If you were wondering what the yellow plastic is, it's heat-resistant Kapton tape. I've placed it over the plastic components such as the flashlight and the rear microphone so that they do not melt because of the high temperature. This area is quite easy to melt, so I'm giving it short blasts with the hot air station so it's warm enough to soften the glue, but not hot enough to burn any components. These MagSafe magnets are really fragile and can come off easily during the glass removal. To save me searching through all of the broken glass again to find them, I'm just going to replace these later. This copper wire might look damaged, but it's just come unstuck from the wireless charging coil. This can easily be pressed back into place and will not affect the wireless charging. This is where the glass breaker hit the metal frame, and it's caused a small dent. I'm going to try to repair it by pushing back on the opposite side. That appears to have fixed it, but I guess we'll have to see once we've applied the new glass. Now it's back into the laser machine to give the housing one more final pass to help remove any dirt and glue that's been left behind. These small rubber gaskets help to prevent dust and debris from getting inside the cameras later on. It's a small touch that I imagine most shops do not do. These are the new MagSafe magnets. They come pre-applied with adhesive on the back so that it will stick to the new glass. We just have to make sure that they're perfectly aligned before we stick the glass on. Now the magnets are in the perfect position, all we need to do is peel off the outer protective plastic and we're ready to start applying the glue. Using the same machine that we used earlier on for attaching the frame to the OLED, we can also apply the glue for this new glass directly onto the housing. Some of the glue's been squashed out the sides, but this can easily be wiped off with a cleaning cloth and more alcohol. All that is left to do in this housing now is to press it. This machine is set to 100 degrees C and we'll press it for about 5 minutes. Then the glue will be fully set. It's taken a bit of time, but the rear glass is finally repaired, and honestly, it's looking really nice. Normally I would use an original housing for this repair because it's cleaner, quicker, and the quality of the glass is better on original housing. But because we're trying to save a bit of money, I'll just replace the rear glass. Aftermarket glass is more fragile than original glass, and this is why you need to make sure that the housing is completely clean before you stick the new glass on. Otherwise, those little shards of glass can get stuck underneath the new glass and it can cause it to shatter everywhere. And that's not something we want the customer to have. This one though is really clean, so we shouldn't have that issue. Before I start transferring all of the components from the old housing to the new one, I'm next going to prepare a new battery. I wasn't going to do this originally because the battery is at 86%, but I want the new customer to be able to have their phone for at least a couple of years before it needs a new one. The battery is at 86%, which is good, but I want this phone to last at least a couple of years before it needs a new one, so I'm going to replace it. To make the adhesive softer, I place the phone on the heat pad at 80 degrees Celsius, and then I add 99.9% isopropanol alcohol around the battery. Using this spudger, I gently pry up the battery until there's a gap just large enough to fit my fingers in. Then I pull up the battery out of the housing. If you've seen my other videos, I removed the old battery management system from this battery and I spot weld it to the new one. This time, however, we're going to try something different. I'm still going to be spot welding a BMS to the new cell, but this time I've got something new to the market. China just released these BMS boards that should allow us to reset the battery health to 100% with 0 cycles. it should also show the battery is genuine. This also means that we no longer have to use the tag on flex method, and we don't need to flash the device after the repair either. This is the Quanly Macron Max spot welder. I've tried 3 different welders, but this is my favourite and works the best in my opinion. If you want one for yourself, the link should be in the description. Now the board is welded in place to the new cell, all that's left to do is to add the plastic protective shield and tape it into place. I'm temporarily placing the battery back into the old housing to test that the phone can still power on with the new cell. Before we can try calibrate this new battery, first we have to fix the camera problem. To remove the camera, we have to first unscrew 1 Phillips and 4 tri-wing screws. After that, we can remove the shield, pop the connectors, and then we can easily lift the old camera out. The original camera physically looks like it's in good condition, but it's not working at all, so we have to replace it. So this camera is from an old repair I did a while back. It's a bit beaten up, the lenses are scratched, and I'm pretty sure the 0.5 ultra wide is completely dead. But before I spend my money on a brand new camera module, I want to see if there's a chance that I can pull the 0.5x lens from the original fully dead camera and swap it to this one to bring it back to life. Basically, let's see if we can build a new camera out of 2 broken ones. As I thought, when I test this scratched camera, the phone only shows the main 1x and the 3x telephoto lens. So yeah, the 0.5 ultra wide isn't working at all. To start this repair, I'm turning the phone off again and then removing the screen and the camera. I'm using some Kapton tape to cover the 2 working lenses here. Although watching this back, it doesn't really make much sense. If this repair actually works, I'll be taking those lenses off and replacing them anyway. I'm using hot air at around about 150 degrees and a scraper to loosen up the glue that holds the cameras together. The heat softens the adhesive and makes the job much easier. But I've got to be careful here, because if the temperature is too high, it could damage the 2 other working cameras. Once most of the glue is removed, I can start by prying the broken camera module out of the chassis. The camera is free from the chassis, so now I use more Kapton tape to attach it to my soldering clamp. I'm now using the hot air gun again at 150 degrees to remove the sticker that's covering the soldering joints connecting the cameras together. By applying low melt solder and some flux, I'm able to easily remove the ultra wide camera using a soldering iron. You can also use the hot air station for this, but you have to angle the hot air away from the other fragile lenses. I did the same process on the original camera lens to remove the ultra wide module, and now I'm just soldering that module back onto this flex. I just hope that it works. Here you can see that I'm soldering each point individually to ensure that I've got the best connection. The soldering is complete, so I'm now cleaning the burnt flux away using isopropyl alcohol. And then we can put it back in the phone to test. After all the effort, the 0.5 ultra wide still isn't showing up. Honestly, at this point it's not worth spending any more time on it, so I'm just gonna have to buy an original camera from eBay instead. It's been a few days and the new camera's finally arrived. It cost me £37.73, that's about $48. Another hit that completely eats into the profit of this repair. The new camera's working perfectly, which is a relief. There's always a risk when you're fixing devices as badly damaged as this, but that's part of the game. Sometimes you win, sometimes you lose, but every repair teaches you something new. And when it does go right, it makes all that trial and error completely worth it. Now that the camera is fully repaired, we can try calibrate the parts. To do this, we first need to update to a newer iOS. In this case, it's 18.7.1. Here's a quick tip for you. When you're using an original pull or a refurbished display, if the proximity flex doesn't match up with the original display, you can disconnect it and the phone will still calibrate successfully. But if they don't match and you still leave it connected, it'll fail. Thanks, Apple. This should have brought up the camera calibration screen, but instead it's saying restart phone. This usually means that something's stopping the camera from calibrating, and most of the time it's due to the LiDAR sensor. In this case, it would make sense because the back glass is completely smashed. So let's try swapping everything into the housing that we repaired earlier and see if that fixes it. Before I get started, I'm removing the old water resistant seal around the edge of the repaired housing. It's much easier to do this while there aren't too many components inside. I'm using 99.9% isopropyl alcohol to soften the adhesive first, then carefully scraping away as much as I can with a blade. Ideally, I'd use a sharper one. This one's a bit dull, so it's taking a bit longer, but that's okay. We'll still get the same result, and it'll let us add a fresh layer of adhesive later to make sure that the repair is as professional as possible. This is the end result. You can see that all of the adhesive has been removed, and it's ready for the new adhesive to be applied. Now all that's left to do is to swap all of the components from the old broken housing to the new refurbished one. First we'll start by removing the camera, then the battery. Next we remove all of the connectors like little Legos. Remove 2 screws holding down the shield to remove 2 more connectors. Now that all the screws and connectors have been removed, we can take out the logic board. We're removing this little bracket because it's hiding some more screws underneath that hold the speaker in place. It's been held down with a little bit of glue, but using alcohol helps me remove it easily without it causing any damage. Just 3 more screws to undo, and then we can remove the earpiece speaker. This then gives us access to the Face ID module. Lifting the shield lets us remove the sensor that was sitting under all that broken glass before. This is the LiDAR sensor. It's paired with the logic board, so if it's faulty or comes from another device, the camera won't work properly. I just hope this one's still working. Now that we removed all the main components from the damaged housing, we can swap back to the one we refurbished earlier and start reinstalling everything. This might be a good time to mention that I'm planning on creating an iPhone repair training series, aimed at people that want to start repairing iPhones, whether it's a hobby, a side hustle, or the first step towards opening your own shop. I'll cover everything from the basics like opening an iPhone safely to advanced repairs and the way to make real profit from your work, even if you don't have all the expensive tools I have here. If you already have a shop, there'll be some tips on how to increase profits by refurbishing parts in-house instead of buying replacements. Right now I'm just gauging interest, so if that sounds like something you want to learn, follow the link in the description and drop your email. The barrier to entry for phone repair is actually really low, and the profit margins can be surprisingly high. So if enough people show interest, I'll start creating step-by-step videos to help you learn how to do repairs to a high standard and make money while you're at it. It's a win-win. So I hope to see you there. Now that all the other components are back in the housing, the only thing left to do is to add the battery. For that, we'll need some adhesive, so I'm using this adhesive sticker on the back of the battery to give it that proper OEM feel. Using this roller helps to make sure that the adhesive doesn't peel off when I remove the plastic. Here's another quick tip. Plug in the battery before you stick it down. Trust me, it'll save you loads of time trying to line it up with the connector after you've already glued it in place. So just before I closed this iPhone for the last time, I did one final check and I noticed that the Measure app wasn't working properly. That's when I realized that the LiDAR sensor was broken, and since it's paired to the logic board, we can't just swap one out from another iPhone. Let's see if there's anything we can do about that. To get to the LiDAR sensor, we once again have to remove the camera and then remove the protective shield again. Then we can remove the LiDAR sensor, and as you can see, it's cracked. This will be why the calibration failed earlier. Using the JCID V1 SE, we can install this board designed specifically for the iPhone 13 and the 14 series camera repair. We attach the LiDAR sensor and it does an automatic test. It says that it's functioning normally, but we know this is not the case. We need to connect the V1 SE to the iPhone and press trust to read the data correctly. Once this is done, we can press Cloud Backup to copy the data. This is the programmable LiDAR sensor from JCID. Unlike the original ones, this one actually lets us write the data easily. Apple really loves to make us jump through hoops to repair their products. Now that the data is backed up on the JCID machine, all we need to do now is to write it to this new sensor. 2 clicks. And it's done. I remove the sticker that protects the lenses, and then we can install the new LiDAR and the camera again. The Measure app is working again, so that means that the repair is almost complete. Now the camera and the LiDAR are repaired, let's try calibrating the parts. I don't show this part, but essentially when calibrating the camera you have to spin around many times until it's complete. And that's it. The phone has been fully calibrated and the parts are showing as genuine or used. You've just seen me copy the LiDAR data from the original LiDAR into the JCID one, and that's the easy way to do things. But altogether, those parts were costing around about £55, and that's too expensive for this project. What I didn't show you was my little workaround. To save money, I bought a donor LiDAR, opened it up, and I swapped the tiny paired chip from the cracked one, and I put it into the new working sensor. That donor part only cost me £5, so it's a much cheaper fix. I just didn't film it because it was too small to capture properly on my microscope. Now that that's sorted and everything's calibrated, we can carry on with the repair. Here I'm adding some 3M primer to a Q-tip so that when I add the new water resistant seal, it will bond better. This foam will no longer be waterproof due to the rear glass being changed, but it will help stop any dust from getting inside. I also apply the 3M primer to the screen as well. This is the water resistant sealant I was talking about. It needs to be aligned perfectly so we get the best bond we can. I then use a spudger to go around the edges of the housing to make sure it's made a good contact. This way, when we remove the plastic, we don't accidentally pull up the new adhesive that we just laid down. Now that the screen's reattached, we can put the last two shields back in place. First the shield protecting the proximity flex, and then the one protecting the battery connector. I always try to leave the inside of the phone looking just as good as it did out of the factory. Here I'm using some isopropyl alcohol, and then I use some acetone to remove any remaining marks. It's always so satisfying to hear that final crunch of the screen as it's stuck down, hopefully for the last time. Now that the phone's fully repaired, let's see if it was actually worth it. The top glass cost £5.95, the rear £7.97, the camera was £37.73, the battery was around about £20, and the broken screen itself cost £20 too. So the total part cost comes to £91.65. So here's the part that might surprise you. I actually paid £150 for this phone. I know that's a lot. Most people would have walked away because you can usually get one in this condition for around about £50 if you're buying it elsewhere. But I found it on an eBay auction and I just didn't want to let it slip away. Now that it's all repaired, it should sell for anywhere around about the £320 mark, which means after parts and everything else, there's probably about £100 profit in it. Not bad for something that looked completely beyond saving. Thanks for watching, and I'll see you in the next one.